Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have some IoT-focused topics, including some vulns in Extreme Networks ExtremeOS, Sonos Era 100 bugs, and some DNS Rebinding research. First, though, I do want to mention that this will be our last set of episodes before the winter break. I would have mentioned that last week, but we didn't do the podcast last week due to some last-minute disruptions. But
Yeah, that was kind of my bad. I went off on a little holiday and Christmas shopping and got trapped by weather, so couldn't make it back in time for actually doing an episode.
yeah, the United States and not wanting to salt roads sucks. But yeah, so January 8th and 9th is when we'll be returning from our winter break. So yeah, just wanted to make that known before we got into our topics. With that said, we can get into our topics now. So yeah, up first we have a post on a VS Code vulnerability, and I'll let Z get into it.
Yeah, it's kind of a fun issue, pretty simple, but title here, it's not a feature, it's a vulnerability. Just kind of a fun play on that classic, it's not a vulnerability, it's a feature sort of, I guess, meme statement, whatever, sentiment from a lot of companies. Definitely seen that. They had this experience with Microsoft's research team or security team in reporting this bug where it is a literal feature that could just be used in a potentially vulnerable way. And it takes advantage of escape sequences. If you're familiar with that inside of like a terminal in your shell, terminal specifically, if you have an escape sequence printed, they're used for things like changing the color of the text that's being displayed, or maybe like the background of the line, moving the cursor around. So if you want to make like an actual terminal UI, you might use those sort of escapes. You can write to different locations on the screen. Um, and they just have a lot of like little functionality like that. And then VS Code expands their support of escape sequences. Um, I'm just wanting to bring up the actual code here, but there we go. I didn't have the link quite ready here, but VS Code has like their standard, uh, or some of these standard escape sequences, and they have this escape sequence, which is the E command. So all of the escape sequences, you basically provide like the arguments you want, and you do your escape sequence start with like the escape character. I think it's a square bracket, and then arguments, and then a function name. Function names are just a single character long. So these are like, we'll see the examples here of A, B, C, D as all these commands being executed, but they're limited to just the single character. And so they have this one that is E. And what that does is it explicitly sets the command line, which is basically like it explicitly sets what the last command run by VS Code was. So this isn't like your shell history where you hit up and you get like the last command or something like that. This is like in VS Code, if you were to rerun a command, this is that command. And it's basically just an explicit shell escape sequence that can be used to provide what that command was. Directly in the output. So all of these basically just come in the output of some other shell command. It puts this output and it'll, trigger this handling. So effectively what that means is any program that can output to, your standard out, it can put any of these escape sequences. So if they are aware that it's running under VS Code and has the shell integration, they would be able to put out this E method or make a call to this E function and provide any command as the last run command. And they have this functionality just because of inconsistencies between different between some of the different terminal emulators there. Like they mentioned conpty may not guarantee the position of where like the command was, or a shell may not even still have the command or the last run command still visible within like the terminal itself, so they wouldn't have any way to access it. And so they created this as like kind of a hack to fix that sort of issue. But as as K9 team K9 mentions in chat, do this. The escape isn't quite the \E. That would actually be the \E is actually, I think, the common escape shorthand for the escape character. It's 1B, I believe. Let me take a quick look here. Yeah, it's \X1B for the escape character. I'm just bringing this up. For those of you listening, you can't quite see this, but you have the escape character, the closed square bracket. I think I might have said open square bracket earlier. Then you've got basically your argument. Well, not your argument. Sorry, I'm highlighting a bit much there. Argument, your actual command, and then this text is being written basically using that command in a sense, or like after that command is activated, so it's able to track all of it. I don't have a really deep understanding of escape sequences. They've always seemed a little bit like magic to me, just kind of a basic understanding of them. They do include a link here actually to a decent little write-up about, and I know we've included links in the past when we've had these sorts of issues, but effectively what this means is anything that can get output on your shell is able to control that last run command. So if you were to use VS Code shell integration and try to run that last command again, they would potentially have access to that. So they use the example of and I seem to have actually lost the window for the topic that we're on. So but
I believe they use a ping for their
well,
example.
they use the example of the ping. They use the example I want to get though was their curl example.
Oh yeah, okay, I see that one. Yeah.
And actually, I've got. Let me pull up the link again here. There we go. Not sure how I lost that, but yeah. So they use the example of just like a file of a catted file that includes at the end here that call to E with the ping command. So setting the last thing to ping. But they kind of just emulate like as though maybe this were a curl request that would happen. Then you control the output of that. Then you would be able to gain control. So I feel like, there's definitely a big ask on this one in terms of being able to exploit this. You need to know that your target's using VS Code, put out this escape sequence, and then also trust that they're going to use like the rerun command inside of VS Code. If they're actively running shell commands, you're probably using, or at least I always use like up and enter, or up a dozen times and then enter rather than retyping a command. But I will sometimes use the VS Code like integrated rerun in some other case. So I could imagine going and having something in as my last run command and then going through in the terminal, and at that point just like running a couple commands, installing a package or something, and the package has this sort of malicious output, and then going to rerun my original command and having it kind of get hijacked at that point. So I could imagine actually falling for this one. It does have a bit of an ask with needing to have the output, but there are a lot of places where you could have the output. As I just said, installing packages is one place. Many sort of builds can include or can have arbitrary information there. If you're catting any sort of log file, you can potentially see things there. So there's a lot of places this could have come up. But ultimately, this was... go ahead.
I was just gonna say before we started the episode, I was talking to you a little bit about it, and I was saying I wasn't sure how practical this really was because it did have so many cases that needed to be working for you, like it being run in VS Code using the shell integration, rerunning the command. But VS Code is popular enough in dev environments, and in like targeted instances, I could see it being reasonable enough to pull off. The package thing that you mentioned I hadn't thought of before, but it's definitely a valid one because I believe we've talked about issues before that have dealt with Node.js packages and stuff. Node.js packages and whatnot, putting output in their installation scripts. So yeah, it's more practical than I initially thought it might be. And it's a pretty cool bug, and it's nice that Microsoft decided to take this as an issue and fix it. They actually call that out at the beginning of the post. That a lot of places will have seen this like, oh yeah, okay, well the shell integration, that's just part of what comes with it. That's the whole idea, so we're just not going to fix this. But Microsoft did take it as an issue and did mitigate it, which maybe you'll get into, or if not, then I'll bring it up.
No, I don't actually have the patch ready to go. I was going to talk about how they actually patched it, but okay. I think they have the link right here, so I didn't take.
I wasn't going to bring up the specific patch, but basically they just added like a nonce to verify the authenticity of the commands, which is a fair way to fix it. Like we've seen that kind of fix deployed for these sorts of issues before, so like with template injection type issues and whatnot. So it's an expected fix, but
yeah, and that's fair because this is the sort of thing that like they added it for a reason. They had a problem that needed to be fixed, and they didn't have a good universal solution without this. So the fact that it exists, like, is something needed. So I think this is kind of a fair thing. Just prompt it, let it be known kind of what's being done there.
well, that was the first way they fixed it. That was like their initial mitigation, but they also did add a nonce later on.
Yeah.
Because in the post they mentioned that the problem with these kinds of prompts is that most people will just click right through it without thinking about it, and I'm definitely guilty of this, and I think a lot of people are. So they did take it a step further too, beyond just the notification.
Yeah, I'm just pulling up that commit also here. Although I'm guessing that's probably I guess I'm following the wrong things here. Want to go to commits, but okay. Yeah, okay. I mean, it is what you described. I just hadn't taken a look at the commits before, so want to pull that up here. But yeah, literally checking that the nonce is provided. Seems fair since, I mean, the internal service that should be adding this is going to know what the nonce is, but any attacker site wouldn't. So, yeah, actually, I mean, that's a better solution. I do still kind of like the idea of alerting on, but as I kind of noticed late on that, they were alerting on every single run rather than a suspiciously modified rerun. Because that's where I when I first heard you mention that they did the notification, I was saying that they would try to detect when it's suspiciously modified. But yeah, especially if it's coming up every time, you do kind of run into that alert fatigue.
Yeah,
And
that's the perfect way of describing it. It's like, yeah, if you see it a lot, you're not gonna want to spend the time reading it. So
yeah, you'll assume it's okay, and if you're like me, I'll click okay, and then it'll click that actually that didn't look quite right. And kind
but
of
then
pick
it's
up,
too late.
yeah, pick up on it
Yeah.
too late. At least that's kind of been the case for me a couple of times. Not quite in this sort of serious situation, but that sort of thing. But yeah, ultimately, it is nice to see that Microsoft did treat this as a bug because it's literally a feature, or did treat it as a vulnerability. And yeah, I mean,
I guess it's an overly permissive feature is how you can think about it. It's too easily abused of a feature, and they took steps to prevent that. So
yeah, and when it comes to like, bug bounty hunting, I think that's an important thing to consider. Like, yeah, a lot of programs aren't going to like calling their features vulnerabilities, but finding ways to abuse the existing functionality rather than just looking for XSS or some really specific bug, abusing what the application lets you do, I think is just an important part of the process too. Taking that time to, basically understand the rules so that you can get around them without
yeah.
necessarily breaking them.
All right, so we can move into our next post, which is a post by Rhino Security Labs on Vulns and ExtremeOS, which they were able to study via virtual machine image.
Great name, by the way, Extreme Operating System.
Yeah, it really is. The marketing on that one, But yeah, so this operating system is mostly used for their managed switches for networking. And because they were able to pull the virtual machine image, they were able to study the raw file system of that VM image and do some auditing. So starting off with issues, one of the first places they looked was the Chalet application, which is a Python-based web app. It uses the Cherry Pie framework for running the web interface. And what's also notable about Chalet is that it runs as root. So it's a pretty nice target to go for. One of the endpoints that Chalet would expose is the terminal endpoint, which could be used to get like an interactive terminal page. And that endpoint also had this static route for loading files. Well, as you can probably guess by the fact we're talking about it on the podcast, that route was vulnerable to path traversal or just being able to read any file. There was no sandboxing or anything going on. And that basically gave arbitrary file read as root, which could be useful for things like reading the configuration file, which has password hashes and such. So from this point forward, they kind of assume that you have some
Actually,
level of access to that
on
terminal.
on the config, I do want to call out that apparently on older devices the hashes were using MD5 crypt, and newer ones are just SHA-256. They don't mention anything about salting, and when I look at these example hashes here, I don't see a salt section in them. So it looks to me as though they're also unsalted SHA-256, and these are hashes that would be, relatively speaking, easier to break, or potentially easier to break, because SHA-256 is not a hash that should be used for passwords. Unless you're doing like PBKDF where you run it like 10, 20, 100,000 times to create that kind of speed loss. But just plain 250 or SHA-256 is still relatively brute forceable. Obviously, different passwords are going to have a different viability there, but I kind of want to call that out, and because I think basically brute forcing it is what they assume for the level of access, because they just call after discovering a method of initial access. We don't actually get like a good vulnerability for that beyond just they were able to get this config file with hashes. So seems to me like that's kind of the route that they took.
It is, yeah. So from this point forward, they do assume you have access to a read-only user, presumably from cracking those password hashes, which, to be fair, as you said, they seem like they would be easier than at least some other schemes for hashing the passwords. So yeah, they assume read-only user. They wanted to see if you could escalate though from a read-only user in the terminal to admin. So read-only user is pretty restricted in this terminal. It can only run a subset of tools, and it can't write anything because it's read-only. But what they did find was another endpoint that could be leveraged, which is this auth token endpoint that they had for authorization and getting JWT tokens. What they noticed, though, was that in order to facilitate IPC or inter-process communication, this token endpoint would basically whitelist the local host, and any request from the local host would just be treated as authenticated, and it would issue an admin token. So any like SSRF that could get requests through localhost to this endpoint could allow you to get that token and escalate to admin, which brings us to the next issue, which was an SSRF via the telnet functionality. So again, this read-only user is fairly limited, but it can invoke telnet. So yeah, by just leveraging telnet, they could send an HTTP request to the auth token endpoint on localhost to get a token. And they had admin. That was a pretty straightforward one. They wanted to see if they could take it further, go from admin to root, which I will say the vendor doesn't consider a security boundary, so there weren't CVEs issued for this issue. But they did find a way to make it happen. And this was through the XSH or execute shell command, which can be invoked on the JSON RPC endpoint. By simply sending a CLI method request to that endpoint, it'll take parameters in the form of JSON and use them to run a command. And with the debug flag or -d, it would run it as root. So you just have like kind of this command line injection issue, and you could run commands as root. So yeah, you could escalate there. Once again, though, that they don't consider that a security boundary. The way they look at it is if you're admin, you have access. Root is not a huge deal from the vendor's standpoint, but yeah, they wanted to see if they could do it, and they could.
Yeah, it's largely an argument injection on that. So like they did get a little bit lucky by the fact that it supports this debug mode. I mean, the debug mode is literally just so the exsh command should step down your privileges to whatever user you're actually authenticated as. So as like an unauth user, it should step down, and so you wouldn't be able to have access to this -d command. But under the web app running as root, it'll still step down, but because it may still step down under normal cases, but because of the flag being injected in there and the web app running this as root, it has access to that flag basically, and it ignores who the actual authenticated user was because root is running it. So kind of like not a desync exactly, but just the two different systems, kind of like the EXSH was probably written under the assumption this is just being written, or this is just being run from like actually SSHing in and getting this limited terminal to it, like coming in as a user or something, having that sort of interface, and not the idea of this web terminal existing. which I would imagine was a later addition to this sort of system, and that kind of difference creates place where this argument injection could be abused. So still kind of a fun issue, even though they didn't give it a CVE. Like, I kind of get it, but in my mind, going from a web shell to an actual root shell is different.
I would treat it as a security boundary.
Yeah, like, I would see that as a security boundary, but it is kind of similar to, like, on Windows going from admin to system. Technically, like, yes, system's more privileged. You're not supposed to get on it. You're not supposed to just be able to do that. But any admin user technically has access to do things, like not direct access to system, but to install service or whatever. And so, Windows doesn't consider that a privilege boundary. And so I kind of get it here too, but
it's kind of just that problem where it's like with admin, you have a lot of attack surface exposed that makes it somewhat easy to get root. And it's just not really worth the effort of locking it down if you can prevent the initial access in the first place. So I kind of understand it in that.
Yeah, no, I do understand it too. Like, I'd still like to call it a security issue, but I also understand why would it be prioritized as like this needs to be fixed right away, because it's already a high level fast to get access to this terminal and stuff. Well, presumably, this isn't being run just on the internet, although now that I think about it, they call out Shodan, don't they?
Yeah, they mentioned that they were able to find over 1,000 devices exposed.
So maybe scratch that.
I mean, it's whenever you get to like IoT type things, it's always a surprise seeing how many are exposed on the wide internet. So
yeah, I mean, people probably don't necessarily think about it, I guess.
Yeah. So that was the main chain of issues. There were some additional issues that they call out. One of which was a little bit of a lower impact one, I guess, is that there's no CSRF protection. They don't use like anti-CSRF tokens anywhere or anything like that. They also found an arbitrary file write as root abusable from Telnet again. This time, they were able to get Telnet to connect to the Redis server port and run arbitrary Redis commands. And, they link off to a post that talks about Redis. I've kind of played around with it a little bit, but not very much. But it is a pretty powerful service to get access to generally, so it's not too surprising that they found a way to leverage that here for file write.
Yeah, if you've got if you're doing the bug bounty, Redis is something I'd argue to like always look for when trying to escalate some issues, because like Redis, it's largely a text-based protocol that you can use, so you're able to kind of spoof the commands or whatever going out to Redis relatively easily compared to like more bespoke or like binary protocols. And you're able to get a lot out of it. Like, it's a common place to get some escalation from. And I do want to call it on the CSRF thing. Yeah, they didn't have any CSRF protection. And the other aspect of that was their same site on all their cookies is set to none. And it had an insecure core setup, which included so it would reflect whatever origin you sent into the access control allow origin, and it would allow credentials. So you can do like basically anything you want with this application just with like fetch requests. You can craft any sort, well, I guess not any sort, because that doesn't let you do custom headers. And there are still some restrictions there, but it is a very permissive setup that allows CSRF here.
All right, so continuing with some IoT issues, we also have a post from NCC Group on exploiting. Sorry, not exploding.
Yeah, maybe exploiting it. That's something hackers do.
So yeah, the Sonos Era 100 speaker. This is coming out of Pwn to Own. The article follows more of a journal-style approach to it, talking about some background on how they got the initial recon on the target and where they went from there, which I will kind of touch on here because I think that's pretty important for these kinds of IoT devices that are somewhat locked down and undocumented. So after opening it up, they found these the UART pads that were broken out. They were able to use that to pull boot logs for the device, and this already gave them some good hints on the setup. For example, it allowed them to discover some documentation for the SoC that they previously thought might be undocumented. That was just because like the packaging had the part number changed. And another thing they were able to find on the board was the embedded multimedia card, or eMMC pins, for the secure flash. While the firmware that's stored on that flash is encrypted, it's still useful to have, and for some of these encrypted firmware, they were able to rely on older research on other Sonos devices, because the boot logs indicated that the Era 100 is pretty similar to other devices they've researched in the past from Sonos. The firmware that they narrow their focus on is the U-boot image for booting the kernel and everything, and they found a number of issues, and they're higher level issues. So the first one they detail is the fact that due to this config end is nowhere flag not being set in U-boot, it will try to automatically load the environment config from the flash at this fixed location of hex 500,000, which if you write there as an attacker, which you can with the eMMC pins, can allow you to control some important environment variables, such as a boot command, and basically bypass the intent of the password locked console. Though they state that the commands you can pass in there are somewhat restricted. So by default, this boot command variable is set to Sonos boot, which is like a custom handler they have set up to load and verify the kernel image. And it'll pass command line arguments to the kernel via the boot args variable, which the Sonos boot handler will try to set before it'll boot the kernel. And this brings us into the next issue they have, which is the unchecked setenv call. So they use setenv to try to ensure that this bootargs variable is set to a controlled value, but they never check to make sure that that succeeds. And that's a problem here because an attacker can actually make that setenv call fail by using their control over the bootargs, the boot command, to pass a flag that sets the bootargs variable as a read-only variable. By making it read-only, that setenv will fail, and the attacker-controlled value for bootargs will get passed through, which is kind of like game over, because then you can just pass arbitrary arguments to the Linux kernel command line, which you can use to pass your own initial RAM disk to get code exec. Though it would be a little bit tricky to exploit at this point, as you would need to pass an address for that RAM disk, and you don't easily have a way of getting controlled data at a known offset, just because of how many things are being verified and how much is encrypted. Which brings us to issue number 3. So the third and final issue is the fact that the firmware has this plain text header that it will use to locate the kernel inside of the blob and everything. And so it has this kernel offset field. But while this field is typically hex 40, where the kernel comes after the header, they don't actually do any validation on that. So by just passing a larger kernel offset value, they can basically create a cave for themselves where there's data that they can pass in that won't be verified against the signature check. And because of that, they now have controlled data at a known offset, and they can pass their initial RAM disk into that cave, and they've pretty much pwned the device. So pretty cool chain of issues. I did really enjoy this one. There is a bit of a low-level aspect that we don't get into a lot on the bounty episodes, but they are higher-level issues, even though they did ultimately use a little bit of hardware hacking to get access to the channels they needed.
Yeah, there is the hardware aspect to this, but I really liked issue 2. This unchecked setenv call, or unchecked calls in general, have been a regular source of issues, just being able to cause errors where the error is unexpected, because it's usually going to work. setenv is not something that you really think of as likely to fail in most cases, but then as it gets pointed out in here, you can cause that to fail. And when that fails, now you've got kind of this foothold to do more with. So while I know a lot of people listening on this episode aren't necessarily going to be looking at this sort of issue, I think that concept of the unchecked values and being able to create errors is a useful thing to keep in mind. Just when you're testing, know where you can kind of create errors and see if they actually cause problems or not, because sometimes those silent points can actually kind of be a source of a foothold or an initial primitive on something.
I especially liked it here because I can get into the mindset of the developers and totally understand why you would think something like a setenv call just can't fail, and so why bother checking the return value of it? So tying in that ability to set variables as read-only in the flags is a really cool aspect of it. And is one of those things that would require getting a fair amount of knowledge on what's going on and the code involved to discover that trick. So yeah, I thought that was really cool as well. All right, so we'll get into our next post here, which is a research post by Intruder on reliable split-second DNS rebinding, and I'll let Z get into this one.
Yeah, and DNS Rebinding, we've talked about it a couple times on the podcast. I don't think it comes up super often, but the general idea of a rebind is just you visit a website, your browser's going to look up the domain name. It's going to go and be like, oh, what's the IP for this domain? It gets whatever IP back. And then if you wait a while longer, make another request after it's already closed, it may need to send another DNS request to get what the IP address is because maybe it's changed. Something's happened that's made it fail and needs to check the IP again, whatever. And then you provided a new IP address. And then once that has happened and a new connection is established to the new IP, your original page can potentially start interacting with this other IP as though it's on the same site because the domain has not changed. The IP has changed, but the actual site or the origin has not, thus giving you some extra privileges. And they go through a little bit of the history when it comes to DNS rebinding, some of the issues there with slow caches, either the browser cache or even your resolver may have a cache. So that makes it hard to actually take advantage of. Go through some history of ways that has been sped up. And then they present kind of their own take that goes against Safari and Chrome browsers. They don't mention Firefox at all here. But the idea comes down to, nowadays, if you're on a computer that has access to the internet over IPv6, the browsers are going to want to query not only for the A record, which is where you get your standard IPv4, but your quad A record, which is your IPv6 addresses for a given domain. And I kind of skipped over where this is part of one of the other attacks, but these records, if you make a record query for a domain, it can include multiple IPs under it. Same deal for quad A. And then the browser itself will decide what IP from that it wants to use and can fall back if one starts failing or whatever. But a lot of times, if you haven't actually run DNS, you may not be aware that multiple IPs can be returned. And that at least kind of matters as you're reading through this. But when it comes to their attack on Safari, actually, and one other thing, in general, the browsers do seem to try and prefer the private IPs. I'm not sure if that's actually the browsers doing a security thing where they're deciding, hey, if it has a private IP, let's use that first, preferring that in a security sense so it doesn't necessarily have this rebind ability because it's always going to hit that private one first. Or if this is really just a side effect of network priorities and this interface accesses the local things and has a higher priority than the actual internet, therefore use that. I'm not sure which side this actually falls on. But the ultimate effect is that private IPs will often end up having a higher priority and get used first. And so you kind of need to get a way around that. You can't... So I guess I will talk about one of the history things here. In 2010, there was a DNS rebinding attack presented by Craig Hefner, who basically presented this idea of using multiple IPs, and you would provide both a private and public IP. It would connect to the public IP. You would have, after that initial thing's loaded, you would kill that off, make sure RST or reset packets are sent out to the connections, and thus make the browser fall back onto the second IP, which is the private IP. And today, they're just going to prefer the private IP, or since it would fall back there, you had the DNS rebind. But today, the browsers will try to use the private IP first, and thus that attack just does not work. So now we come on to their newer attacks, which takes advantage of the fact that there's a query for the A record and a query for the quad A record. And what happens is in Safari, if you return one of those first, it doesn't wait for both of them to finish. So if you return the public IP first, say that's going to be your A record, you return an A record with the public internet IP first, it's just going to use that. And if you delay that quad A response, it'll end up using the first one which is the public IP, load all of that properly and establish that first connection. And then you respond with the quad A request, and that's going to be your private IP. The quad A response will then start getting used at the next connection. It'll be like, okay, well this private address is more important to use, has priority, and let's start using that, creating a very quick DNS rebind. You don't need to wait for like any sort of caching issue, which is nice, or any sort of cache to be resolved. And because you're not sending them both in the same packet in this case, or in the same response or whatever, but you are kind of getting them together so you could have this rebind happen very quickly within a reasonable time frame that somebody might be visiting your website. They call this is like split-second DNS rebind because it can happen very quickly as long as the one arrives first. So that's fun, but that is specifically against Safari, so presumably he could use that on like an iOS device running Safari, but I don't think they call that out specifically. I would just, oh, actually they do. I say I don't think they call that out specifically as I literally have it on page. I've tested in Safari and Brave on iOS and found that this technique works. So yeah, this works on the mobile devices on iOS. And then you come down to their Chrome attack. And Chrome, its priority system's a little bit different. It's going to prioritize the local IPv, or it's going to prioritize IPv6 first. If you have an IPv6 record, you can access the internet on IPv6. It'll prioritize that first. So the local IPv6 has the highest priority, then your public IPv6, then local IPv4, and public IPv4. And so with that setup, you can basically return the A record on just for your IPv4 record, that's going to contain your private IP, and you're going to use the quad A record to be a public IP. So it's going to be using kind of the second and third categories there. So it's going to use the public IPv6 first. So you have that initial setup happen. You kill that connection, so it ends up sending the TCP reset packet out, which will make Chrome go, hey, okay, this server's dead, we need to try another server. It may retry, you need to keep sending RSTs potentially, but ultimately it will fall back on that internal IP or that private IP that comes from the IPv4 record, again, creating that very quick rebind of the DNS record. Unfortunately, as they call it from here, this plan almost worked, but you couldn't make requests as though we're the same site, and that's because Chrome has a partial implementation of this private network access concept. I guess I'm not sure what I want to call it, but kind of taking an expansion on like, you know, same site and things like that. This with private network access, it adds one of the first things at least Chrome implemented from this was adding cores to private requests or to private IP. So if you make a request that comes or a private network request, so what that ends up meaning is a request where the IP server or the IP of the server making the request. Actually, let me flip that around. If you make a request where the target IP is more private than the IP of the initiator of the request, then it's going to require like a CORS header saying, you know, access control allow private network to be set to true. Basically adding CORS onto private network requests. So your public website just can't make this request over without passing a CORS pre-flight check, which is a nice addition, but they don't have it for iframes. You can iframe your own website, so you're iframing the same domain. You can iframe that site that now has the DNS rebind, so it's going to a local IP, and then just use JavaScript to access the DOM of your iframed page and add JavaScript to make requests from there because you have full access to it because it believes you're on the same site. Because you're not going cross origin, you're not going across sites, you have full access to that DOM, you can just go ahead and add more scripts to access or to start making the JavaScript requests from the private site in the iframe. So it's really just like a missing implementation detail. I didn't read through the entire spec here, but I didn't see any real call out of adding this sort of functionality to it to actually deal with the idea of an iframe being loaded and accessing like that, because that, like, the access to the iframe kind of comes down under same site, which usually doesn't differentiate based off of IP, but based off a domain name. Whereas, this stuff in cores has its impact when it comes to fetch requests and like XML HTTP requests, not an iframe, which is making a full request over to another site. So I'm not sure, how they're going to approach resolving this, because it does feel like a pretty glaring issue to say just limit iframe access to. But I haven't seen anything that's going to be clear about what the plan is to sort of approach that. So at least for now, that is a way of getting around it. I wouldn't expect that to last forever. They called this like not a security issue because PNA isn't totally done yet. Like I said, I didn't give a full read through of this spec to know exactly what it's supposed to do, but for now, like, this very much feels like a glaring hole in that implementation. But also just interesting, the different priorities coming back on the main attack here to get the DNS rebinding. Because DNS rebinding has often felt fairly clunky and not too trivial to do in a lot of cases. So it's nice to see something that feels rather practical in this case. Although I am somewhat interested, like, presumably Firefox didn't work here, or they may not have tested on, but if it didn't work on Firefox, I'd be interested as to what Firefox is doing differently, as to why this didn't work, if they're not doing the same prioritization or what's going on there. But it is a interesting omission to me. But I guess
I was thinking the same thing. I was going to ask you if you had caught what the difference was, but yeah, it sounds like you're in the same boat as I am, so can't really get any resolution on that. And yeah, I did a quick search in the post and I couldn't really find any call out to it, so
yeah, which is
but yeah, it's certainly an interesting attack.
I mean, in fairness, like, the majority of browsers are Safari on mobile or Chrome based. On mobile also, actually, with Android, and on desktop. Like, that is your vast majority. Firefox is, I don't know what the actual stats are now, but I want to say it's like maybe 5 to 10%. Like, it's not a huge market share, but it's still,
it's actually, I think it's lower than that.
It
it's
might
looking
be.
like
I was trying to be generous, but the number in my head was like 2, but I'm not actually confident in that.
I think it's about 1%. I'm on a chart here, and it's
either way, it's not
it's low.
I'd put it simply as it's not necessarily a major player, but the more interesting aspect is just what's the conceptual difference that means it's not working on Firefox. If it's not, maybe they just didn't test it at all and didn't care to test it. But it does feel like the sort of thing that Firefox might be doing something a little bit different that just means this attack isn't practical. Like, maybe they're, waiting for both lookups to finish or something like that with the Safari version, or something going on there.
Sorry, what was the number you guessed for Firefox market share? I was curious, so I did pull it up. Like,
I had guessed 2, but I had mentioned
it is
5
a little bit
to 10.
higher. Yeah, so it's at 3.2% as of last month. So
okay. So Rudimal asks, I wonder if the extra security in Chrome breaks any websites that have DNS load balancing. So an important thing, actually, with the private network access, before they fully rolled out what we were just talking about, they did actually run it in a warning mode, so that they could find out if there were a lot of websites breaking or if they were creating a lot of issues by introducing this functionality, and then went forward with actually enforcing it all the time. And that happened back in 2022, I want to say around July, or like it was during like that early summer period in spring where they were doing a lot of this work, or at least that's the last time I saw updates on it. Maybe they've done more, but I would assume because they saw the stats as maybe not breaking a lot of things. And as for doing DNS load balancing, I don't believe that should, because that should all be, so if you provide, the load balancing there, you're going to be providing public IPs on the internet, not private. So the request shouldn't hit that private aspect, because they're kind of at the same level. The only place where this kind of applies is when the targeted website has a more private IP, which, did they call it out specifically here? I know I might have got that term out of one of Google's things and not from this spec file, or this draft report, whatever. But more private IP is just going to be like your reserved addresses, as I'd understand it, reserved addresses to public. Like, I only really see a difference between public and reserved or private IPs. There's maybe the third class we want called loopback with localhost. Yeah, it's kind of third class on it, but beyond that, like, I only really see the two differences, and because DNS load balancing is all going to be public IPs, it shouldn't create an issue there.
All right. So, do you have anything else you wanted to say on DNS rebinding, or should we move on to shoutouts?
No, I think we can move on to shoutouts, and I'll just jump right into that with first one I've got the Google Translate link here, although I'll pull up the original document too, which, there we go. So it's Chinese post. There's been a struts bug, so Apache Struts, that I've seen talked about a reasonable bit. And it seems to basically be a sort of parameter pollution, case sensitivity, desync sort of issue. However, I tried getting through this post. I could not get a good handle on exactly what was what this process was for this to happen, because it seems like, one, they're using some of the showcase code, which is just demo code for how to do a file upload, but may not be how an application does it. Although it's vulnerable if they're using a similar pattern. And then the best information I had was really looking at the proof of concept, which is somewhere in here, but they basically sent, I might actually need to go to the original because it might have been in a picture here. But they basically just, yeah, it is in pictures. They basically just ended up sending like the a different case across. The image here isn't exactly what I was thinking it should be, but having like a capitalized U in the upload versus not. And it seems like the case. So I did look at the patch. The patch was basically making making the parameters here case insensitive, or at least having the ability to do case insensitive lookups. So it seems like what would happen is that if you provided a different case, if you provide the same parameter but with a different case, one of them would get checked and validated for like the path traversal issue, or path traversal here when uploading a file, and the other one would not. But I'm kind of unclear, but this was a bug that I saw talked about, so I didn't just want to not mention it on the episode at all, but I didn't find a really good write-up of it. Several of the write-ups just kind of refer to this post, and I couldn't get a lot out of it, unfortunately. So, wanted to call it out. There is this sort of struts bug that seems to be that may impact, some older, well, now older struts versions, but relatively newer versions. So you may still be able to find this, and it is kind of a fun issue when you have those case sensitivity things. I just don't get the full flow for how this one works to go too far into detail. Spectre, you have anything you want to add on that one, or can I just go on?
No, you can go on.
All right. And then, I've got two other shoutouts here from Portswigger. Blind CSS Exfiltration. I've honestly only actually done this on a CTF, but I have seen a couple bug bounty write-ups that have need to do this. So they kind of cover the main way, or the primary way that this was being done. You'd have either a pretty large style sheet, or you may just use imports and import chaining to get all the potential values in there. But the idea was that you would just do these lookups, like value, like you look for the input value starts with letter A, and then if you get a match on there, you set like a background image so that it creates a URL request, and then you do like AB, AC, and you kind of do a bunch of that. They walk through all of that, but now CSS has support for the has selector, which there were ways around this before, but makes it a little bit easier to take a div, and then the has selector is basically saying, like, select this div. They have the example here of div has input value equals 1337. So it'll match any div, and then it looks has, and then if any of the children of that div or anything under it matches whatever statements inside the has statement, so in this case, this input value equals 1337, if it matches there, it'll set the background on the div itself. Which just means when you're setting the background, so if you're matching on like a hidden input, you can't set a background URL that's actually going to make a request. Talk about combining this with not. So it's just like a newer technique that feels a little bit cleaner, a little bit easier to write for doing this CSS, blind CSS exfiltration. Also provides a script to kind of run a server that provides or that can generate some of these CSS files that you can use. So yeah, basically the new thing here is just that is the has selector, worth knowing about, worth keeping in mind. Also just a good write-up over doing this blind CSS exfiltration, but that is kind of the main new thing here. And second shout out I wanted to make here is another Portswigger thing. This time it's a feature in Burp. I just thought it's kind of cool that they've added this, which is Bambdas, as they're calling it, which is basically like an easy little scripting language. I think kind of being inspired from the idea of like lambdas and having just a small function that does something can be called, or you might call it over like mapping it over everything in an array or whatever, for like filtering requests. So they use the example here of just a simple statement to look for all requests that redirect and have a body over 1,000 bytes, indicating maybe they didn't stop script execution after they did the redirector. They have more complex here, like JSON endpoints with no text HTML MIME type and a variety of options for that, coming down to like a full little script. But I thought it was an interesting introduction to like this new feature. I believe you're only going to be able to use this as like Burp Pro, but still looks like an interesting feature to write like really quick lookups, basically. They call it like mini extensions, but to just add really quick checks into Burp, which I would have loved to have back when I did more of the consulting stuff, because I had a lot of these checks that I would run like a mini HTTP proxy behind Burp that I would then be able to take a look and interact with things through and kind of work with Burp that could flag requests for me. But this would have been a much easier way to do some of that, having it built right into Burp. So yeah, those are the 3 shoutouts I've got for this week.
All right, cool. So, as always, thanks goes out to everyone who tuned in. Previous episodes can be found on Twitch, YouTube, Spotify, Apple Podcasts, and more links on Anchor. And our Discord and Twitter links are also down below or in the chat. We will be back for tomorrow's binary episode at 7 p.m. Eastern, 4 p.m. Pacific. And once again, just a reminder that next week and the week after, we will be off for our winter break. For those of you who only listen to the Bounty episodes, happy holidays, and we'll see you after that. Otherwise, we'll see you tomorrow for our last binary episode before the winter break. We'll see you then.